We are now in section 2.6, limits at infinity, and this is our first example. Hopefully you've read through the first page of the notes, and don't think there was anything there I needed further explanation from me. But let's say I wanted to evaluate a couple limits, and this is limits as x approaches infinity in this first example, first part here, part A. The limit as x approaches infinity, in other words, as x gets unimaginably big and positive, right? X approaches infinity, of the function 5 plus 1 over x. So this is really a sum of two functions, so I can break it up into two limits. The limit as x approaches infinity of 5, plus the limit as x approaches infinity of 1 over x. So the limit of a constant is always that constant value. It never changes no matter how big x gets. This function, this y value will always stay 5. So that limit is always 5. Then the limit as x approaches infinity of 1 over x. As x gets bigger and bigger, I'm taking 1 and dividing it by a bigger and bigger number. 1 divided by a million, 1 divided by a billion, 1 divided by infinity, right? It's getting closer and closer and closer to 0. If you want to look at that function, it's up here on this first page. Here is the function 1 over x. As x approaches infinity, the function is getting closer and closer and closer to 0. That's two ways to think of this. Sometimes I like to think about just plugging in a big number in my head. Okay? So the limit as x approaches infinity of 1 over x is 0. So 5 plus 0 is 5. Now I have the limit as x approaches minus infinity of pi times the square root of 3 over x squared. Now I can think of this as the two functions pi times the square root of 3 times 1 over x squared. So I'm going to break that up into the product of two limits. The limit as x approaches minus infinity of pi times the square root of 3 times the limit as x approaches minus infinity of 1 over x squared. So the limit of a constant stays a constant. So that stays pi times the square root of 3. And again, as x gets bigger and bigger, now bigger negative, so minus a million, minus a billion, minus 10 trillion, minus infinity. 1 over x squared gets smaller and smaller, and this x squared stays positive. It really doesn't matter, but 1 over a gigantic number, whether it's negative or positive, would get closer and closer and closer to 0. So pi times the square root of 3 for the first limit times 0 is equal to 0.